Imagine using the exact same mathematical code that's designed to calculate, like nuclear missile trajectories or aerospace structural integrity, just to legally force a corporate PR department to tell the truth about why your app crashed.
Yeah, I mean, it is a massive misallocation of computational power, and honestly, that is precisely what makes it such a brilliant piece of engineering.
Welcome to today's deep dive. We are jumping right into a software project called HERESY. Specifically, we're exploring two pull requests number 10 and number 11 from the project's repository.
Right, and we've got our hands on the actual developer notes, the commit messages, and even the automated AI code review logs.
Yeah, so for you listening, if you've ever just stared at a green check mark on a cloud status page while your app is completely broken, you're going to absolutely love this.
Because we are really looking at an intersection of, highly rigid technology and very slippery human behavior. It's a fascinating case study.
Okay, so before we get too deep into the weeds here, let's just establish some basic groundwork. We're talking about pull requests, or PRs. For someone who isn't a software engineer, what exactly are we looking at?
A pull request is, well, basically a proposal. When a developer wants to change a piece of software, they don't just shove the new code in secretly.
Right, they have to show their work.
Exactly. They bundle their changes and submit a pull request to the main project repository. It's a way of saying, here's the code I want to add, here's what it does, and here is my reasoning.
Makes sense.
And then other developers, or in modern cases, artificial intelligence bots, review that proposal before it actually gets merged into the official software.
So we are essentially reading the documented conversation in the receipts of how this specific software was built.
Precisely. And the inciting incident that kicks off PR number 10 is an actual real-world outage that happened today, August 17th, 2026.
Oh, wow. So this is fresh.
Very. The developer documented a snapshot of a major cloud provider status page. And the underlying data showed roughly 20% web and API errors across the board and a massive 50% failure rate for raw downloads.
50%. That's huge.
It is. But the public-facing status page described this using these wonderfully sanitized corporate euphemisms, things like degraded performance and degraded availability.
Wait, hold on. Let me get this straight. A normal developer looks at a 50% failure rate, finds the root cause, and just pushes a patch to fix the servers right.
Usually, yes. That's the normal path.
But this developer sees the outage, sees the corporate spin, and decides to build a massive, complex software architecture just to mock it. I mean, isn't that an incredibly petty waste of time? Why not just fix the servers?
Well, that is the natural reaction. It seems petty at first glance.
Yeah.
You have to look at the architectural choices they made here.
Well, I'm listening.
Because this wasn't just a quick angry tweet. They built HERESY version 7.1.0, which they titled the Enterprise Reliability Emulator. And they chose a technology stack that is, frankly, entirely theatrical.
What do you mean by theatrical?
Well, they used Ada, Fortran, COBOL, and POSIX shell scripts just to process the outage data.
Okay, let's unpack this, because that list of languages sounds like a history lesson from a 1970s computer science textbook. I know they're old, but why those specific languages?
Because they're the foundational languages of absolute, uncompromising bureaucracy and mathematics. Take Ada, for example. Ada was originally designed for the Department of Defense. It's heavily used in aerospace and aviation because it is just obsessed with safety and rigid boundaries.
Right, it's very strict.
Extremely. So in this developer's program, the outage data first hits the Ada gatekeeper. And Ada's job is to validate the error percentages.
Meaning what, practically, like in terms of the code?
Meaning, if the system tries to process an error rate of, say, 101%, Ada doesn't try to guess what you meant. It doesn't, round down to 100. It instantly rejects it.
It just shuts it down.
Exactly. Ada establishes the absolute mathematical reality of the incident. It forces the data to be logically sound before anything else can even happen.
So Ada acts as the bouncer for the joke.
Yeah.
Once the data passes that strict check, where does it go next?
Then it is handed off to the Fortran runtime. Now, Fortran was developed in the 1950s for high-performance computing. We're talking weather prediction, fluid dynamics, missile trajectories.
Heavy-duty math.
Right. It is built to crunch numbers deterministically. So Fortran looks at that validated 50% failure rate for raw downloads. It runs the math, and it categorizes that failure rate with a highly specific output.
Oh, I saw this in the notes. It prints out, statistically speaking, this is a coin.
Yes. It's brilliant.
That is amazing.
Yeah.
Because a 50% failure rate is literally a coin flip. It's mathematically proving the absurdity of calling a coin toss chance of success a mere degraded performance.
Exactly. It uses high-level physics mathematics to deliver a deadpan joke. But it doesn't stop there. Next, the data moves to the COBOL terminal.
And COBOL is like ancient business software.
Yeah, COBOL is the classic language of business, finance, and mainframe administrative systems. If you have a bank account, COBOL is probably touching your money at some point.
So what does COBOL do with this data?
It generates a very official-looking Enterprise Reliability Report. And right in the middle of this bureaucratic layout, it displays the message. Packages normal. One employee has reported for work.
A completely administrative punchline, just dripping with bureaucracy.
And finally, all of these separate language components are tied together and executed by a POSIX shell script.
Right, I've seen that term in the notes. What exactly is a POSIX shell script?
So POSIX is a family of standards used to enter compatibility across different operating systems. A POSIX shell script is basically the lowest common denominator, rock-solid way of issuing commands to a computer system.
Like the plumbing.
Exactly. It's the plumbing holding the Ada, the Fortran, and the COBOL together. And that shell script wraps up the entire sequence by printing to the screen. As stupid as it appears, it is actually very good at status pages.
I am trying to wrap my head around the sheer effort involved here. The best analogy I can think of, it's not like they built a vault to protect a joke.
Okay.
It's more like they built an insanely complex titanium, laser-calibrated mousetrap. Like, the trap physically cannot snap shut to deliver the punchline unless exactly 50 grams of pressure, or in this case, exactly 50% validated download failures is applied to the cheese.
I love that analogy.
If it's 49%, the trap stays open, no joke is delivered.
That is a brilliant way to conceptualize it. The mechanism itself enforces the determinism, and the developer explicitly outlines this in the commit notes. They establish what they call an evidence boundary.
Oh, right, the mathematical rules.
Yeah, they actually wrote out logical inequalities in the documentation to govern the code. They wrote, status PAGE euphemism is not equal to observed failure rate.
And one normal service is not equal to a healthy platform.
Exactly.
They literally codified the difference between corporate spin and reality.
They did. And crucially, they explicitly state that the code will refuse to invent a root cause for the outage. The program does not care why the servers went down.
It's just observing.
Right, it just holds up a mirror. It reads the public status page, reads the raw data, and processes it strictly, exposing the massive gap between the sanitized corporate language and the stark mathematical reality.
So they successfully built this heavily fortified machine to process facts and spit out satire. But this is where the source material takes a wild turn.
Oh, absolutely.
Because if you build a machine specifically to process facts, what happens when the underlying logic of your comedy is flawed?
The machine audits you.
Yes. The developer submits this pull request, and it immediately gets reviewed by an automated AI, the ChatGPT's Codex connector bot that operates in the repository.
It is becoming very standard in software development, to have a large language model automatically scan new pull requests. They usually look for syntax errors or security vulnerabilities before a human even looks at it.
But this AI didn't just look for syntax errors. It actually audited the logical mechanics of the jokes themselves. The bot left these incredibly detailed review comments pointing out logical bugs in the satire.
How did it frame those bugs? Like, what did it say?
Well, for example, at 13.45 in the timeline of the outage, the original status page snapshot showed an aggregate status of roughly 20% errors across all experiences, pull requests, issues, actions, everything.
Okay, so a broad outage.
Right. But the AI noticed that the developer's code was taking that 20% aggregate error rate and falsely narrowing it to apply only to the pull request service.
Which fundamentally changes the narrative of the outage.
It totally does. The AI bot effectively said to the developer, hey, if you project this aggregate observation as just a pull request issue, you are creating a service event that the source data does not contain. Yeah. The AI caught the code being factually inaccurate in its setup for the joke. But the part that actually made me laugh out loud reading these logs was what the bot flagged in that COBOL script we talked about earlier.
The administrative punchline about one employee reporting to work?
Yeah. The bot noticed that the COBOL script was programmed to print packages normal, but it was programmed to do it unconditionally.
Meaning it didn't check the data first.
Right. Even if you fed the system a debug file that showed the packages system was completely down and on fire, the COBOL script would still blindly print packages normal. It was hard-coded to tell the joke regardless of the facts.
That breaks the developer's own evidence boundary rule.
Exactly. And I really struggled with this part initially. Like, how does an automated code reviewer essentially debug the delivery of a punchline? I mean, how does a machine police comedy?
Well, what's fascinating here is that the AI wasn't judging the humor at all. I mean, an LLM has no actual concept of comedic timing or what is funny.
Right. It doesn't have a sense of humor.
It only understands variables, logic flows, and data schemas. It was simply enforcing data integrity. The developer explicitly laid out the rules for this program, claiming it was deterministic and strictly tied to the source data.
Oh, so the AI just held them to their own rules?
The AI just read those rules and held the developer to their own contract.
So it's acting as the ultimate comedic straight man.
Precisely. It looks at the logic flow, sees a line that says, print packages normal, then it cross-references that with the data schema, which shows the variable packages status can equal down.
And it spots the contradiction.
The AI flags the logical disconnect. It essentially told the developer, you cannot present a derived joke as if it were supported by the observation when the observation says otherwise. If packages are down, you mathematically cannot make the package's normal joke.
It told the developer their satire was logically unsupported, which is just incredible.
And this raises an important question philosophically. If your satire is based on exposing the truth behind corporate spin, doesn't your satire also have to be rigorously provably true? If you are making up facts to deliver your punchline, aren't you just doing the exact same thing the evasive corporate PR department is doing?
That is a brilliant point. And reading the commit messages, the developer clearly took that AI critique to heart. They didn't just fix the little code bug. They completely redesigned the architecture around it.
To enforce the truth.
Exactly. This leads us right into pull request number 11, where they introduced HERESY version 7.2.0. They upgraded the system into a full-blown public relations response simulator.
They basically formalized the AI's accidental lesson about truth and comedy.
Here's where it gets really interesting. They built this new simulator entirely in Fortran, and they called it the Clarke and Dawe GitHub PR Response Edition.
Clarke and Dawe.
Yeah, for you listening, if you aren't familiar, Clarke and Dawe was this legendary Australian comedy duo. They were famous for these deadpan, highly structured public affairs interview sketches, where one played a relentless interviewer and the other played an evasive politician or PR person.
And the developer used Fortran to procedurally generate that two-person interview format.
Yes, but with one massive addition. They added a strict new rule to the code base called Punchliner requires supported precondition.
Oh, that's perfect. The joke now legally requires data to compile.
The 50% coin toss joke will only execute if the observed download error rate in the data file is exactly 50. The package's normal joke only runs if the package's status is verified as normal.
It has to match reality.
If you feed the program ambiguous data, or if there's a duplicate record, or if the numbers are malformed, it doesn't try to guess. It doesn't generate a slightly different joke. It shuts down and refuses to output anything.
In software engineering and security, we actually call that failing closed.
Okay, let's clarify that for a second. Failing closed, is that like when a website just gives you a blank 404 error instead of trying to load a broken, messy page?
It's a bit more absolute than that. Think of it in terms of a digital security gate.
Okay.
If the fingerprint scanner is dirty and can't read your fingerprint clearly, it doesn't say, well, it looks somewhat like your fingerprint. Come on in.
Right, that'd be terrible security.
Exactly. It locks the door. It fails close to protect the system. If it can't verify the truth, it denies access.
And this Fortran program applies that security concept to truth and comedy.
Exactly. If the percentages don't match or if the evidence is missing, it fails closed. It refuses to speak. Now, contrast that with how human public relations works. Corporate PR almost always fails open.
Because silence is bad for the brand.
Right. If the data is missing or the root cause is unknown or the facts are just embarrassing, a PR department doesn't just shut down and refuse to speak. They generate pleasantries. They smooth over the gaps.
They spin it.
They fill the silence with phrases like, we are experiencing an unplanned service disruption and are actively investigating. They invent a narrative to keep the conversation going and manage perception even when they have no actual facts to share.
Wow. They fail open to fill the void. But this Fortran code cannot do that. It refuses to. Let me read you the exact dialogue this Fortran program generates when it runs successfully against the validated 50% outage data.
Go for it.
It outputs a transcript that reads, interviewer. So a download was, statistically, a coin toss. Public relations. That is a very binary description of a cloud
That's
service.
so good.
Interviewer. Was the platform healthy? Public relations. Some services were operating normally. Interviewer. That was not the question. Public relations. It was adjacent to the question.
Adjacent to the question. I mean, that is just the perfect distillation of how corporate evasion works.
And then at the end of the simulation, the program ultimately confesses. The PR entity states, no, this exchange is fictional satire generated by Fortran.
Beautiful.
And the system formally closes out the script with this system message. Heresy in a purse statement complete. Nothing further has been clarified.
Nothing further has been clarified. It is incredibly self-aware. And again, the language choice is the punchline. Fortran demands absolute precision, and public relations is an industry designed to avoid precision at all costs.
It's a complete artistic statement using the tools of software engineering. And it extends beyond just the code itself, right? The developer wove this philosophy into the entire bureaucracy of the project. In software development, you have things called CI workflows, continuous integration.
Right. Every time a developer updates the code in a repository, automated test scripts, the CI workflows run in the background to make sure the new code didn't break anything.
Usually they're pretty boring.
Yeah, usually they have very boring names like build phase 1 or run test suite.
Not in this project. The developer gave their automated tests incredibly passive-aggressive names.
I noticed that.
Every time they submit code, a workflow run's called Enterprise Reliability, Cloud, still concerned. Then another check runs called CI passed, Mainframe, still disappointed.
That's hilarious.
And for this new PR simulator version, they added a workflow titled Public Relations, Nothing Further to Add.
They've turned the automated, invisible infrastructure of GitHub into part of the Satire itself. It's so thorough.
So what does this all mean? Thinking about you, the listener, navigating this world of constant software updates, app crashes, and those inevitable vague apologies for degraded performance. Why go to all this immense, complex trouble just to mock a random Monday status page?
Well, if we connect this to the bigger picture, what the developer is doing here is making a profound point about how we consume information in the digital age.
Right.
We are constantly surrounded by highly engineered, deeply artificial corporate communications. When a major service goes down, the apology you read isn't a human emotion. It is written by committees, vetted by legal teams, and polished by PR algorithms until it means almost nothing at all.
They're essentially formulas designed to neutralize anger.
They are. And by taking that corporate spin and literally turning it into a deterministic input-output machine built in a 1950s mathematical programming language, the developer exposes the mechanics of that spin.
They lay it bare.
Exactly. They're showing us that degraded performance is just an equation. It's an output designed to manage your perception. But when you strip away the spin and force the machine to look at the raw mathematical numbers, the reality is simply that your download is a coin toss.
It forces you to question the underlying assumptions of the information you are being fed every single day.
It demands that we look at the data boundary. The code explicitly says uptime badge is not equal to current reality.
Yeah.
How often do we just accept the green checkmark on a dashboard or a headline from a press release without asking what the actual raw failure rate is? This project is a rigorous mathematical reminder that the map is not the territory and the PR statement is not the reality.
It is brilliant. So let's quickly recap this incredible journey we've been on today. We started with a random Monday where a major cloud service was having a bad day. 50% of raw downloads were failing.
Yep.
A developer looked at the vague corporate language used to describe that outage, and instead of fixing a server bug, they built a titanium mousetrap out of Ada, Fortran, and COBOL to immortalize it.
Then an automated AI reviewer stepped in, acting as the ultimate straight man. It didn't critique the humor, but it rigorously audited the logic of the developer's jerks, proving that you cannot deliver a punchline without the data to back it up.
Which led to the creation of a Fortran-powered public relations simulator that is legally, mathematically obligated to tell the truth about corporate spin.
A machine that fails closed.
Exactly. It refuses to generate a joke if the underlying data doesn't prove it.
It creates an environment where falsehoods literally cannot compile.
Which leaves me with a final thought for you to mull over today as you go about your digital life. If a lone developer can write a Fortran script that strictly prevents a PR simulator from spinning a joke without the hard mathematical data to back it up,
Right.
what would happen if we applied that exact same fail-closed rule to the actual PR departments, the news feeds, and the corporate communications we consume every single day? Imagine a world where if the empirical evidence doesn't perfectly support the claim, The spin simply refuses to compile.
The silence would be deafening.
And maybe deeply refreshing. Well, thank you for joining us for this deep dive into the sources. Stay insanely curious, keep questioning the status pages, and we will see you next time.